Good afternoon. I am S.P. Agrawal, faculty in Water Resource Department of Indian Institute of Remote Sensing. Currently, I am heading the department. Today, I am going to talk about remote sensing in GIS application to flood mapping, monitoring, and management. So, first of all, what do you mean by flood? A flood is an unusual high stage in a river. Normally, the level at which the river overflows its bank and inundates the adjoining area. If you look at this figure, you can see this is the cross section of the river. Now, this blue cyan color is the water. Now, bank is here. So, whenever the water is there up to below this bank, then there is no problem. But because of the heavy rain, this water depth of the water will increase in the river and it will cross the river bank. Then it will start inundating the adjoining area, and this is known as the flood. This is the photograph of a city where flood water is visible, and you can see here this river, when that stage of the river increases or depth of the water increases, it inundated the surrounding area. India is a flood-prone country. In fact, it is one of the most affected countries in the world. India accounted for 1/5 of the global death count due to the flood. Now, of course, because of the technology intervention, space technology, and other communication technology, it is deaths are decreasing tremendously. Around 40 million hectare land is affected by flood in total. However, every year, sometimes it may be 2 million, sometimes it may be 6 million land is affected. In fact, millions of the people are displaced annually. So, what are the causes of the flood? The first and foremost cause of the flood is the heavy rainfall. Whenever there is a heavy rainfall, there is a chance of a flood. Now, it may be because of dam break. Sometimes it happens because of the heavy rain, entire dam is filled with the water, and because of the water pressure, dam breach is there. And you will find at the downstream area, lot of flood inundation takes place. Third one is the breaching of the embankment. You know, whenever there is a heavy rain, river start flowing, and both the side of the river, many places you will find embankment. You can see in this picture. Now what happens, because of the water pressure, this embankment is breached and water start inundating the surrounding area. So this is another very major cause of flood inundation. Especially in delta area, you will find such type of problem frequently. Sometimes even in urban area which is protected by embankment, you will find such type of problem. Then another one is the drainage congestion. Especially in urban area, what happens? You can see Delhi is a quite frequent, lot of, whenever there is a heavy rain, you will find in Delhi city, inundation takes place. It is mainly because of the drainage congestion, because drainage capacity is limited and there is a heavy rain, so drainage cannot carry away the entire amount of the water, so you will find lot of congestion, drainage congestion, you will find the inundation area. So these are the causes of the floods. So how to map the flood? Before invent of the remote sensing, generally we get the information from the people. There were some authorities like flood department, Central Water Commission, they used to inform. Now also they are providing a major role. Nevertheless, now we have a very important tool which will give you a direct inundation mapping. The tool is basically remote sensing from satellite. We get the information from the satellite. It may be optical sensor, it may be microwave sensor. For flood mapping and monitoring, we need both the sensors, optical sensor and microwave sensor. So let us talk about the optical sensor and what is the principle of flood inundation mapping. Generally, water absorbs 90% to 95% energy in optical band. If you can see this figure, This y-axis is basically reflectance, and x-axis is the wavelength. Blue and NIR, in between you will find green and red. What you see here, entire energy is absorbed, especially 100% energy is absorbed in the NIR region. So if you compare with the vegetation, in NIR region, vegetation reflected around 50%, while water reflect only maybe 1% or sometimes 0.5%. It means in any FCC which is of NIR red and green belt, water appears black. You can see in this imagery, all the water body appears black. But if you see this, whenever we are talking about the satellite imagery, we always talk about the what you call different tone, like red color means vegetation, cyan colors, it may be building, it may be soil, open or bare soil, black color, it may be water. But the second important thing is it is not only tone, it is the texture. Like if you want to differentiate between a sand area and a urban area, sand area you will find a smooth cyan color, while in urban area you will find the texture of fragmented cyan color. Zigzag cyan color, you will find road network, all these things. So, black color means water. So, wherever you will find this black color in any FCC, we say it is water. Now, how to say what is this? For example, if you see this imagery, what is this water? Black color, yes, it is the water. Can you see some small dots of the water? Black color, it is a water. What is the basic difference? Difference is you have to see not only the tone, you have to see the shape. Now look at these maybe the ponds or lakes or tanks. While this is a big water body, it is a regular water body, clear water is stopped, it means it is a reservoir. So that's how we interpret imagery. Now, when it is a flooded water, then what happens? Flooded water is mainly a shallow water and it has a lot of sediments. So flooded water will not appear black in any imagery. Flooded water will appear in cyan color because it consists of the water and the soil. So combined spectra will come and you can see the tone. So you can see the second image, right image, you will find all this cyan color, it is basically the flooded water. Hence, in any optical imagery, flooded waters appears, flooded water will be in the cyan color or maybe some bluish tone or something like that. Okay, now, whenever we have, actually why we have the flood? Because of the heavy rain. And this heavy rain comes from where? It comes from the cloud. So, there is a problem. Whenever there is a flood, we have a lot of cloud. Hence, optical data will not help us. Optical data cannot penetrate into the cloud and any optical imagery will look like this. You can see all white. You cannot see any flooded area here. Hence, many times it is very difficult to find out the flooded area, to map the flooded area, to monitor the flooded area using optical data. Hence, we have to look into some other solution, some other wavelength. And we found microwave is the most suitable wavelength because it is having high wavelength and it penetrates into the cloud. So, even there is a cloud, you will find the flood inundated area. Let us see the next image. You can see here this is the Mahanadi Delta and you can see here it is the Mahanadi River. This is Luna River, this is the Chitrapala River. Those who are from Odisha, they can identify these rivers. This is the delta. Now what you see, there was a cloud, but you can see all this black is the water. However, this black, you can see the shape. So this cannot be, this is basically a river. This is basically a river. This is basically a river. But all these areas where you will find lot of dark area, black area, this is all flooded area. So it is very easy using the micro data to get the flooded area. Of course, how to separate out this river area from the flooded area? If you have a satellite imagery, it may be optical also, before flood, then you can digitize all this river, permanent water body and river area, and then finally you can detect from this entire image black area, then you will get only the flooded area. Now, question arises, why water appears black in microwave region? The answer is, water is a smooth surface. It is an active data. So what happens? Satellite sends some signal, it strikes to the water body. Water body behaves like a mirror, so there will be a specular reflectance. Hence, suppose satellite is sending signal here, then there will be a specular reflectance. Satellite is still there, so it will not receive any data. It will go away. So satellite will not receive any data, means it will be black. So this is the reason due to specular reflectance, water appears black in. So flooded area will be black. So what will be the black? Water body, flooded area, any river, all these things will be black. When you separate out permanent water body, you will get all flooded area. So that's how we map the flooded area. This is the basic principle. In optical data, there is no cloud, you can use optical data. Because it is number one, it is cheap, it is easily available. And also you can see that other land cover also. But then if there is a cloud, then there is no other. That is the reason why our reset one we are using, whenever there is a flood, we are using reset one data, which is a microwave C-band data for flood mapping. Now, what are the platforms orbits available for flood mapping? In fact, in all remote sensing, basically we are talking about three orbits. One is the airborne orbit. Airborne orbit means basically whenever there is a need we fly. It is very costly, it is time to time, it is not possible, always it is available, sometimes it is not possible, it is, every time you have to fly, so it is very costly. However, it is only, if you have to fly 2 km to 8 km, like aeroplane, you have a sensor there, but we are not using it, unless it is emergency. However, the other or two orbit, LEO and GEO. LEO means all these satellites which we are calling remote sensing satellite, basically it is around 600 to 800 km away from us. We call them remote sensing satellite because comparatively we are very close to Earth. They are in very high resolution. Resolution of 80 centimeter, 5.8 meter, 23.5 meter, 56 meter. All these satellite sensors which you are hearing, basically it is the sensors, the satellites launch in this orbit. This is known as the LEO orbit, or generally we are calling them polar orbiting, because it orbits from pole to pole. And once it orbits, it takes some time, like 90 minutes or 100 minutes. By that time Earth will move. So first time it will be at one point, second time once it will come, by that time Earth will move, so it will capture another area, like that. So repeativity, maybe after 21 days or 22 days or 23 days, sometimes in 5 days, you can cover the same area. So the advantage is it has a very high resolution. Disadvantage is repeativity is poor, maybe 20 days, maybe 5 days, maybe 10 days. Then we have another set of satellites which are known as geostationary satellite, which is far away, 36,000 km away. Since they are very far away, you must have heard about INSAT series, Kalpana 1. All these INSAT series are used, but they are very far away. So the advantage is, if they are geostationary, always at top of you, so you get picture every half an hour. In fact, you can get picture every 5 minutes also, every 10 minutes also. So it is decided, okay, half an hour is okay. So every half an hour we receive the picture and you can monitor the system. 3 satellites cover entire world, so they are good for telecommunication. Hence, all geostationary satellites are also known as communication satellite, except few like Kalpana 1, INSAT 3D. You must have heard about Kalpana 1, which is a lot of data about weather data. Now we have INSAT 3D, which is giving weather information. Why it is providing weather information? It is good for weather information. The reason is weather is a very dynamic phenomenon. For example, you wanted to monitor the cloud movement, cloud type, cloud top temperature every half an hour because it changes. So every half an hour you want to monitor it, then you should take the every half an hour data from inside. So advantage is repeativity is very good. Every half an hour you are getting the picture. But disadvantage is, since it is far away, 36,000 kilometers away from the earth, hence the resolution is very good. It is around 8 kilometers, 4 kilometers or 1 kilometer. So they are very good for weather mapping like cloud cover, cloud top temperature, even rainfall estimation. There are different techniques. It is very good. Hence, we can use these two orbit. One, so suppose you can see this satellite, heavy cloud is there with cloud top temperature less than equal to minus 40 degrees centigrade. It is sure this cloud is raining there because at minus 40 degrees centigrade, vapor cannot withstand, it has to condense, and once it is condensed, it will convert into the drop, and drop means because of the gravity, it has to fall down to the earth, so you will have a rain. So these parameters are available, it is available on the net. You can, if you are interested, you can look into the imd.gov.in, and every half an hour you will find pictures are changing, images are changing. So these two orbits are very important even for flood mapping. However, we are interested how much area is inundated, which road is affected, infrastructure damage we are looking for. So for that, this satellite, this orbit is very good, and there are many satellites. Now, some satellites I have of course listed. Reset 1, it was launched. It is basically C-band. It is very good when there is a cloud. We have Cartosat 1 with 2.5 meter. We have ResourceSat 1, is 56 meter, LIS3 23.5 meter. Then we have LIS4 with the 5.8 meter multispectral. Then we have a Cartosat 2 with pencrometer data of 0.8 meter, 80 centimeter. So if you are looking for infrastructure losses, this satellite is very good. There is some road damage, you can capture, you can acquire this data, you can order this data to NRS, you get the data and you can see the damage assessment. If you are looking for the only inundation area of the crop, then you can buy LIS3 23.5 meter or AWIPS 56 meter. So then ResourceSat 2, of course, nowadays it is available, AWIPS with 56 meter, LIS3 with 23.5 meter and LIS4 with 5.8 meter. There are many more satellites. Suppose there is a flood today and there is no pass of Indian satellite. Then we have to acquire the foreign satellite like RadarSat, ERS, whichever is available, it can be acquired. There is an international charter. If you cannot acquire, you can ask some other country who is providing the data and you can get the information about it. Now, let us start one by one. I am starting from 98, one by one, and then of course I will come to 14 also. How we do the entire process? Basically, whenever we found, of course, I should mention here that there is a center at National Remote Sensing Center, DCN Support Center, DSC, who is responsible for operationalizing of flood mapping monitoring of India, and they are providing information. So the order steps I will tell you how they do. Basically, when there is a flood, they found there is a flood either by seeing the INSAT series of data, INSAT 3D data or Kalpana 1 data or from any other source, like there is a heavy rain, passage of heavy rain, with models also now there is a possibility. They get this information, then they acquire the data. For example, this is one example. Big data was acquired in 98, Brahmaputra, very famous Brahmaputra flood was there. Now what do you do? So once you acquire the data, you georeference this imaging. This is very important because whatever imaging you are getting, basically it is without georeferencing, a computer will understand only row and column. You have to georeference. Georeferencing is referencing with respect to geo, referencing with respect to earth. So you have, once you reference it with respect to earth, then You can see on your screen the real world situation. Wherever you click, you will find the lat long. So you can match with the ground. Once it is done, then in your GIS environment, you have different layers like state boundary, blaze boundary. You simply superimpose. Overlay. Once you overlay, situation arises like this. Your attention here. This is a satellite image. Now, it is georeferenced. Then a district boundary of Assam was overlaid over it. Now, what you see in this image, nice forest area, agriculture area. But then you can see cyan color, all this along the river, Brahmaputra river. Brahmaputra river is not that much, wide. It is basically Brahmaputra river plus flooded area. So if you separate out Brahmaputra river, you can see the flooded area. Immediately you can find out which district is affected. For example, see here Barpeta district is affected. Maybe so you can go further. Sonitpur little affected, Maribam affected, Karbi Angalam is not affected. Like that, immediately once you superimpose, immediately you can find out which district is affected. So this is the first step. Acquire the data, georeference the data, superimpose the boundary. That is district boundary. Now you start analyzing one by one district by one district. Suppose there are different scientists, so work is assigned to different scientists. Now, let us take Maribam district. Now, what happens to Maribam district? So, you wanted to know in Maribam district how many villages are affected. So, in your GIS environment, you have a blaze boundary. You superimpose the blaze boundary over the district. Now, see this picture. This is the Maribam district. Then, you superimpose the village boundary here and immediately you will get, you can count, immediately of course GIS will give direct answer, immediately you will get how many villages are affected. 1, 2, 3, 4, if you count, it is 465 villages are affected. Not only that, in your GIS database, you have all the information about these villages, like name of the village, population of the village, maybe agriculture area, whatever information you will have, it will add on to your information about the flooded area and effect on the area. It may be building, it may be population affected, all these things. So all these things, in fact, if I remember in maybe before 2000, that total turnout time of all these things was 24 hours plus. But nowadays, this can be done in maybe 6 hours or even less, sometimes less than 6 hours. So by DSC analysis. Now, but then when I was talking about this image, basically I am looking for overview of sort of thing like which area is affected, which district is affected, how much agriculture area is affected. But if you really wanted to know infrastructure loss, then this type of resolution of 180 meter is not good, even 56 meter is not good. For that you should have a high resolution which is less than 10 meter. Even nowadays we say it should be less than 2.5 meter or you less than equal to 2.5 meter. I will show you one image which is having 5.8 meter resolution to give you the information about the road damage. So you can see next, this is the pre-flood road. You can see very nicely a line here. This is the pre-flood road area. But you find during the flood, you can see this white spot. Basically, the water is inundated. It is inundated. The road is inundated. So such type of thing you can map. The advantage of such type of mapping is you can plan whether suppose you want to rescue some villagers or you want to send some relief material like food or blankets or maybe other thing, cloths, whether by lorry you can reach there or not. If you are not reaching by lorry, then of course you can plan for sorties, helicopter sorties. So this type of information is very useful not only to understand the damage but also to plan for the helicopter sorties, and this really our relief and rescue operations, it improves a lot and it reduces the cost of sorties because you can optimize the sortie. So lot of saving of the fuel. This is another picture. You can see the high resolution picture, road network, and all these things, and you see the flooded area. But then question arises, sometimes you say it is not only the area of the flood, it is also important what is the duration of flood. You can understand like that, suppose there is a paddy field, month is August, generally paddy field means a lot of water is there. A flood comes, let us say for 1 feet for 1 day. How much do you feel that entire paddy crop will be disturbed, or you will not get any yield? No, you will get, there is no problem with the paddy. It means basically the duration is very important. So it is not only the inundation mapping, but duration is also important. And these three images of the same area will show you that how to get the duration. For example, of course, if you want to have duration, you should have everyday image. But of course, weekly will serve the purpose. You can see here, I need your attention. This is 4th September, 13th September, and 19th September. What you see here, black color. This is flooded area. On 13th September, same area is flooded. But you can see here, 19th September, it is not flooded. So I can say the duration of flood is 19 minus 4. So duration of flood is less than 2 weeks. Similarly, you can see here, flood is there, but there is no flood. So 13 minus 4. So duration of flood is less than 9 days. But what you see here, you can see flooded, here also it is flooded, here also it is flooded. So here the duration of the flood is more than 15 days. And I can tell you, this is the area where entire thing will be destroyed. All crop will be destroyed. So accordingly you can assess. This analysis is very good, not only for damage assessment, for even planning for government department that how much money we should give to the farmer. And not only that, for insurance purpose also this type of analysis is very useful. This is another area. You can see all black is the flooded area. Just 2006, 2008. You can see here. This is Orissa flood. You can see black flooded. 18th September you will not find very little, but 22nd September you will find all these areas flooded. Maybe in detail you take a close up. This is the Bhadrak district. You can see here 22nd September lot of flood was there of 2008. So you can map it, and if you have a village boundary and all these things, superimpose it, and you will get all these information which I have told you earlier. Now this is a classical Kosi flood. It is not only mapping, but if you have an everyday image, you can monitor. This is a classical example. You can see here, this is before flood, river is flowing nicely, and this is all low-lying area, but a good agriculture area. What you see, there was a breach here, then flood inundation started. You can see the second image. What you see here, there was a breach, and then on 22nd August, you found that flood goes up to here only. After that, you will not find any flood. But after 2 days, you find flood reach up to here. You can see all black. But after 10 days, you will find flood reaches finally to the Ganga River. So you can really monitor how flood started, reach up to here, finally reach up to here, and you can see up to 10th September flood was there. In fact, some of you may remember it, Kosi flood. In some pockets, it was there for around 2 months. So this type of monitoring you can do using the remote sensing data. This is another example of 2010 Leh flood. You see before flood and after flood you find all mud flow. You can get, this is a Cartosat 1 image. I want to highlight here, basically if you see lot of synchronization of that event of flash flood. It came in cloud west. You can see here cloud is generating. This is from every tower image from Kalpana 1. You can see it is generating, cloud is continue to be there, and if you know the cloud top temperature and other information, you can say it is raining, and entire cloud, totally it was burst. Very heavy rainfall downpour was there in a small valley, and lot of loss was there. So you can see before and after, so you can map like that. So whenever NRSC generate the flood products, what information they give basically? They give all information like not only the flooded inundation area, even a river network, road network, railway line network, even railway line, inundated railway line, road inundated road, all these information they provide. So this type of product is available, will be given to the concerned authorities. So now let us come to that element which we get from the space using the remote, of course, remote sensing, like space input to flood disaster mapping, monitoring and management. So far I was talking only about the water body of flood inundation area mapping and monitoring. But when you want to predict for future, then you have to have a lot of information from the for modeling. So what are the information we get from the remote sensing? You know that digital elevation model. Famous one is the Cartosite Dam, which is available on our website. We have Aster. These are the two dams which is basically through stereo pair, optical stereo pair. Then from radar, SRTL is available now free of cost. Land use land cover map is also important. Pre and post disaster event. So you can differentiate. Snow cover time series maps. It is required basically when there is a snow melt and heavy snow melt is there. Sometimes not in India, other country you will find. Sometimes it is there because of the heavy rain, heavy snow melt. You will find flooded downstream. But of course, snow melt under modeling. This is very important information. Then SAR image, of course, during cloud cover you get. High resolution image you get for infrastructure losses. River cross section, please know that whenever, especially in hilly region, cross section changes when there is a flood. In fact, not only in hilly region, if you go to even a plain area also, because of this sand deposition and meandering of the river, a lot of river cross section change take place, and you can monitor it. Then precipitation, of course, from INSAT 3D or Kalpanavan, or maybe from TRMM data. Satellite communication is required for information and information transmission. Then, of course, GPS satellites are required for positioning. You have, the GPS is the American system. GLONASS is a Russian system. Then we have our own IRNSS also. It's a regional navigation system. So these systems are good, very useful for point information. Then you have an integration of RS data and GIS. So GIS platform is required, so you can integrate that. And of course, use of GIS tool for watershed and river parameter estimation. So a lot of GIS free softwares are available as well as commercial softwares are available. Like ArcGIS is a commercial software. Mike is a commercial. Nevertheless, HGO, HMS, all these softwares are SWAP models and all. These models are basically free models available. Maybe tomorrow when I will talk about hydrological modeling, that time I will discuss all these modeling part. So, in any disaster, there are three phases: preparedness phase, during the disaster, and post-disaster. So, preparedness phase, what are the requirements? Preparedness means I should have a proper forecasting and warning. So, what are the requirements? I should have a rainfall information. Of course, all other parameters, meteorological parameters like evapotranspiration, temperature. Hydrological information I should have like river basin characteristics, slope, land use land cover, soil, drainage information, river characteristics, water level discharge, warning dissemination system I should have. What remote sensing provides you? Like INSAT series will provide the rainfall, data collection and communication it will help, while IRS series will provide us land use land cover, soil, slope, drainage, etc. Response and recovery phase. So immediately response. What do you need? Evacuation, impact assessment, flood extent, flood damage, restoration. What remote sensing GIS will provide you? Optimization of the routing, flood mapping, abrasion, submergence of the crow, submergence of the road, submergence of the rail, duration of the flooding, depth of the flooding. Requirements for mitigation phase. Basically, the mitigation means you want to avoid such a scenario when there is a flood, heavy flood. So you should have some structures like embankment, dams, non-structural measures like flood hazard zoning. So what remote sensing GIS will provide you? River configuration, bank erosion, status of the embankment, whether it's a breached or not breached, flood hazard mapping, drainage congestion area, etc. Now I put this topic cyclone because though I am not supposed to cover it, but cyclone brings lot of rain, and because of those rains, lot of flood takes place. So how you manage it? Let me go further. Of course, this is see whenever there is, as I told you, it is not only one satellite, it is not only one sensor. We have many satellites, many sensors. It's up to us which satellite is available. This is a classical example in Odisha cyclone. Of course, nowadays also same practice we are doing. You can see here, someday inside field 1D was available, someday IRS 1D was available, sometimes IRS 1C, these are the dates, radar set, IRS P3, IRS 1B, SP4. Even during Hudhud and Phalanx, some satellites were available, some not available. So whatever is available, we have to acquire the data and immediately we have to prepare the information. Now you can see cyclones, it is not only affect the infrastructure of urban area. Classical example is the Hudhud of Visakhapatnam. How he created the havoc in Visakhapatnam. But the first it create impact on it simply destroy the lifeline of the port, and the lifeline of the port is the jetty, where ships are load and unload. You can see here, this is the jetty, which is visible before cyclone, and after cyclone it is not visible. So you can map using the high resolution data. So all infrastructure damage you can, I can show you, this is one example of Hudhud. You can see all inundation areas. This is close to Visakhapatnam, Anakapalli of Visakhapatnam district. You can see all inundated area of Hudhud. This is the image of 13th of 2014. This is the another image. You can see here before cyclone and after cyclone or during the cyclone. You can see all area is inundated, all black. This is what do you call? This is 2013 feelings. You can see here. So all these images, just I'm browsing, changing it. You can see here before cyclone and after cyclone. You can see a lot of flood takes place. So this is basically inundation. Another image. Okay, so now I was talking about all mapping and whether it is in cyclone or because of the heavy rain or because of the drainage congestion, how you map the flooded area. What are the different sensors? You can use optical, you can use microwave, whichever is available you should use, and then you can separate out river area and all these things. You can see the permanent water body, and finally you can nicely make a flood map. Then you can see which road is affected, which building is affected, which railway line is affected, and provide all these information. But the most important thing in planning is prepare for the future. So, can I prepare a flood risk zone map using some methods? The answer is yes. How? The technique is very simple. Generally, see the past and predict the future. And that is basically where we call it a frequency analysis and what you call probability distribution function. So let us try to understand. Here I am going to show you the integration of statistical models, remote sensing and GIS, and how it is converted, those three technologies converts to get the flood risk zone map for next 100 years. Now, first what we do, we are using here Gumbel technique. This is basically extreme value approach. So extreme, this is used for extreme events. So basically flood is the basically heavy rainfall, so heavy rainfall is an extreme event. You need not to worry about this form. Basically, this is the equation which says the variant of x means the depth of the flow in the river is equal to mean of the flood event of n years plus frequency factor into standard deviation. So how we do? We get the past 30 years data, and every year there is a maximum river flow is there. So we take that data. So every year one data. So like that, past 30 years, minimum 30 years. If you have a 50-year, your modeling is very good. So 50 years, 30 years, minimum 30 years data. Then we calculate the frequency factor, which is a function of various parameters which includes the recurrence interval, time, or we can say return period. So we calculate that, and then we calculate the mean of all the data. Suppose in 90, we start from 71, some depth is there, let us say x1, 72 x2, 73 x3, like that x1, x3, or like that you can x up to xn. So sigma xi divided by n, that is the mean. Similarly, standard deviation is calculated, and then frequency factor based on the formula, and you will get the information about the xt, means particular return period. Like say in 10 years return period, what is the probability? What will be the flood that in 10 years it will again repeat, or it will exceed once in 10 years? So this is the probability. So we get this information, the depth we get from this formula. Then, so you can see here, the x value, sigma value, k value, add up all, you get this information. For 5-year return period, this is the information. For 100-year return period, this is the information. Now, the next step is, what we do? We take this data. Now you know water attains the same level, same surface, smooth surface. So we assume that whatever level water is there, water level is there in the river, same level will be there on the ground. So if we have a DA, we give a command in GIS. If water level is equal to, or let us say xt is equal to, digital elevation model is equal to, less than equal to number xt, then it is a flooded, otherwise flooded. This is a simple GIS command. I will repeat again. If digital elevation model is equal or less than 2, the xt, then there is a flood area, otherwise not. If you give this command, you will generate the scenario. Then you superimpose the FCC and scenario is generated. In next slide, you can see this. What you see here with the same command, you can see here, this is the river which is flowing. This is the Ganga river, this is Yamuna river, and you can see 5-year return period. You can see only small area is generated. Main city is still, there is no problem. 10-year return period, more area, 25 years, more area, 50 years, more area, and you can see 100-year, maximum area is covered. So it means that next 100 years, how much area, say urban area will be covered because of the flood? If we assume that same flood will continue, like last 30 years frequency will continue, so this is a probability distribution function, satellite imagery, and that data. We integrate all these things, and such type of scenario is generated. Now, where these scenarios are useful? These scenarios are useful for the planning. For example, this city, I want to protect this city for 100 years. So I know the depth for 100 years here. So if I have an embankment of this much height, more than this height, if I can construct here an embankment of more than this height, then I can save the city for next 100 years. So this is very good for planning, number one. Number two, there is another option. I can tell the people, gentlemen, this is the flood prone area. Please don't construct any house there. So this is the preparedness. So by using the flood hazard map or risk zone map for different return period, I can prepare for the future threats. Then this is the modeling part which I may cover tomorrow, but I can tell you what actually people want from us. People are not interested about what is the depth and all these things. They want, suppose this is my house, at what time water will come to enter into my house. Suppose this is a road. What time water will come to this road? Whether it is coming or not coming. This is very important. So molding will help you. Molding will tell you, see, this is the river. Suppose a certain amount of rainfall occur. This is the, along the river, how water will move and down as per the time. Along the cross section, how it will move. And finally, it will inundate here. So this is our target and we want to know that. So for this, we have to do the hydrological modeling, flood modeling. There are different models. There are a lot of remote sensing GIS inputs are required, and this will give a lot of information. For example, I can tell you, many of you must be hearing, sometimes there is a flow in the Yamuna river in Delhi, and it comes like that, by tomorrow, or generally in the news it comes, at tomorrow 4 o'clock it will cross the danger line. How these engineers are calculating? Based on the models, based on the mathematical models. They convert into, they have a hydrogram, they know this much rainfall occurs, this much water is, started flowing from some other dam, released, then of course it will cross that. So this is a mathematical modeling, which is finally hydrological modeling. So you get all this information. So this type of things are there using the remote sensing GIS and finally hydrological. Okay. This is a disaster which I want to mention here, and from this disaster we realize the importance of early warning system. Kedarnath disaster, everybody knows. People are talking about it for last 1.5 years. What lessons we learned from this? The most and foremost was the communication. Maybe by phone or even a transport. No road was there. When all roads, in between all roads were, flushed down to the river. Lot of landslide were there. No communication. Because tower was destroyed. Tower were destroyed. All towers, maximum towers either destroyed. If not destroyed, then there was no diesel, there is no power. So that you will not have any signal. Then there was no real-time information like what is the extent, how much damage has occurred. Was there any other alternate mode of connectivity? Day-to-day monitoring. So then, question arises, how to avoid such type of scenario? Then, this will lead to the forecasting and prediction, and we have to operationalize this through early warning system. So, next few minutes, I need your attention. I will concentrate on early warning system for flood. So, what is the component of early warning system? Early warning system means prediction of heavy rainfall event. Then, a database like land use and cover, 3D footprint map of house infrastructure, topography, digital elevation model, cross section of the river, soil parameter, etc. etc. Then hydrometeorological observations from the field, online, and finally hydrological simulations, hydrological model. So what are the requirements? Requirement of early warning system for floods are field observations for river flow path and transmission of data in real time. There are many rain gauges. There may be river flow depth gauges are there, but how to transmit the data to the server so that every minute I get this information, and this can be achieved by relay, transmission either through a SIM card or through satellite, like automatic weather stations with real-time transmissions. Nowadays, every half an hour ISRO has a set of automatic weather stations where every half an hour data is updated, and we are receiving the data. If you don't have the data, then by SIM also it is possible. At IRS, we have two centers. In Himachal Pradesh, one near to Hamirpur, one near to Manali, above Manali in fact, near to Koti. Every 5 minutes we are getting the data about the weather, like temperature, rain, all the information we are getting. Then I don't know whether there is a possibility of Doppler weather radars. They give a lot of information. Satellite are based observations, cloud cover conditions, wind vector, cloud top temperature, outgoing long wave radiation. There should be, so this information I need every half an hour. Then software. There should be hydrological models and there should be a prediction models. So this is required for early warning system. Now how to achieve it? So automatic weather stations, we have seen that using the even a telephone SIM, we get every 5 minutes, or through satellite transponder also we are getting information. This is already working well. River flow depth, CWC has many centers where they transmit the data. But now there is a need that in such type of hilly terrain where a lot of cloud burst takes place, we should have this information. Then satellite-based observation, of course, this is always available on the website. There is no issue in it. Anybody can browse. Then software's models, it is available. Some free models are available on the website. Any means you can download it. If you are a hydrologist, you can download all these models. And some weather forecasting models are also. So there are different weather prediction models where WRF means weather research forecast model. So this is and this is Indian WRF. So it was further modified for Indian conditions. Now you can see this is the WRF model. I don't want to go in detail because this is the which have a lot of information you have to provide, like land use land cover map, digital elevation model, previous meteorological parameter, then predict for the future. So some exercise we have done here at IARS Dehradun, and you can see here when there was event after that we started working on it, and this is I think 24th and 25th June, and we have checked with the IMD data also, and accuracy we found was not very bad. It is not very good also, but not very bad, and you can see we could able to predict, actually we could able to predict the high event here, you can see here, we could able to predict, but the actual amount, it is still the accuracy was around 60% or something like that. But for high event, even suppose there is a 200 millimeter rain and we say 120 millimeter rain, at least we can say this is a high event. Be ready for it. So the total, what is the total conceptual framework? First, we should have all the database in my GIS environment. Second, we should have a WRF model or any model. In fact, this is most famous model. People are using it. Even our own meteorological department is using this model. So, provide all the information, past data, then you predict for the future. You will have a rainfall for next. Generally, if you see the accuracy, 3 days accuracy it gives very nicely. So you know that you will get accuracy of 80% to 90%. After that, you will maybe accuracy may reduce. But this is important. Next 3 days you should predict properly, so that you can tell the people, gentlemen, you may have a flood. The next step is once you have a rainfall information for future, let's say next 3 days, 4 days, then you assimilate all this data to your hydrological model. Maybe the rainfall data, predicted rainfall data for tomorrow, day after tomorrow. Maybe all these watershed characteristics, rainfall, river information, cross section and all. Run the model and you generate the scenario like that. Okay, this much area will be inundated, this much area inundated, this much area will be inundated. Like that, you can generate different scenarios and provide to the government organization or NGOs, whosoever you want. So this is the future work actually we are planning, total conceptual framework. So what we have done here, we have simply, this is the total framework, physical framework we have done. Entire things have been conceptualized, model is set up. Now once we get the information of the weather forecasting, we simply complete the process. So I'm looking forward to it. That's all from my side today. Thank you very much for your kind attention. If you want to write more, kindly contact me at spa@irs.gov.in. Thank you very much.